2.1 conclusion for Math 135. This was after watching the Math 130 1A, B, and C. Okay, so let's go ahead and look at g of x equals x plus 2 for when x is less than 2. Okay. Then we're going to say g of x equals 2x plus 1 for all x greater than or equal to 2. Okay, so we have less than 2, greater than or equal to 2. Notice these are equations of lines. So now let's look at a, which is the limit of x approaching 2 from the left of g of x. X approaching 2 from the left of g of x. Okay, remember we're approaching 2. So for approaching 2 from the left, that's right here, these values. So we're going to use this equation, and we're going to go ahead and evaluate and put the 2 in there. 2 plus 2 is 4. Okay, now remember it's approaching 2, so we can say that the limit is approaching 4. It doesn't equal 4 as far as g of 2. We're going to say that it approaches 4. Okay. Now, what about g of 2? Well, that would go in this equation. Okay, so let's go ahead and write the limit of g of x as x approaches 2 from the right. As x approaches 2 from the right, that's where these numbers come in. Okay, all numbers greater than or equal to 2, so the greater than 2. So we're going to evaluate, this is a line, so we can evaluate it. Putting it in there, we have 2 times 2 is 4 plus 1 is 5. Okay, if we take the limit as x approaches just 2, well, looking at the left and the right, they're different. So this does not exist. Okay. All right, let's do another one. So these are evaluated without actually having to graph. But this one I want to graph just to show you what this one looks like. We have x plus 1 for x not equal to 1. And we have a 4 for x equal to 1. So let's look at that. We'll just draw a quick little graph. We went out 3 here, 4 here. Okay. All right. So let's just do this one where x equals 1, we know that y is going to be 4. So here's 1, 4. Okay, we know that one for sure. Now where x does not equal 1, let's choose some points. For x not equal to 1, we're going to use x plus 1. 0 is not equal to 1, so we have 1, 0, 1. Okay? Negative 1 is not equal to 1. If we put a negative 1 in there, we get 0. Negative 1, 0. Okay? Let's choose something else. How about 2? 2 is not equal to 1. If we put a 2 in there, we get a 3. 2, 3. 1, 2, 3. Now we see we have a line here, but we have an issue because when it equals 1, it is 4. So when it has 1, it goes to 4. So for this particular line we're looking at, we're going to put an open hole right in there in this line. Because these are all x values right here. These are all x values that do not equal 1. And we're going to put them into this equation of this line. Okay? All right. So now let's look at the limit of these. I'm going to erase this. The limit of f of x as x approaches 1 from the left. Okay, so here's 1. Approaching 1 from the left, like at here, we go there, and here, and here. And where are we going to? That's right. We're approaching this number right here, which is 2. Let's look at f of x, the limit of f of x as x approaches 1 from the right. So here we are from the right, we're going this way to 1. At 3 we have here, 2 we have here, a half we have here. So as we get closer and closer to 1, it's still going to 2. Now that may look confusing because f of 1 is 4, but approaching 1, the limits approach 2. So now let's ask the question, the limit of f of x as x approaches 1, are these the same? Yes, they equal 2, so that's the limit. Even so, I'm going to say note, f of 1 equals 2. But the limit of approaching 1, f of 1 equals 4. F of 1 equals 4. But the limit, as we get close to 1, it's approaching 2.